So on this video, we're going to be going through the odd questions, okay? And all of these are dealing with absolute value functions. And in order to really understand absolute value functions, you have to know the vertex form of absolute value functions. So if you forgot it, you might as well write it down up here. It's y equals a, which is kind of like the m on y equals mx plus b. Y equals a, absolute value, x minus h, close absolute value, plus k. Okay, and we all know that the most important point is the vertex. We should know, based off of yesterday's notes. And the vertex is a coordinate, the most important point, and that's the hk value. So technically, whatever you see right here, if you see a -3, you think opposite on h. So if you see a -3, it's going to be a +3. If you see a +7, it's going to be a -7. If you see a -1, it's going to be a +1. Always think opposite of on h, and you always take k for what it is. So if you see a 5, then your y value on your vertex is 5. If you see a 1, your y value on your vertex is 1. Anyways, you identify that point, and then from that point, you use your a as rise over run to find your other points from that vertex. So if you weren't here yesterday, this is what we learned, that using that form, you first graph your vertex, which is the hk value. And of course, think opposite on h, and you take k for what it is. And then after you graph that vertex, then you rise and run according to the a value. And you do that in both directions, right? Now, what I mean by both directions, you're gonna, like, let's say the fraction is 2/3. The fraction that's out here in front is 2/3. You're gonna rise 2 and run 3 to the left and to the right. Let's get into it. Let's do number 1. So if you're not feeling too comfortable about this, write down the word vertex, because that's the most important point. And the vertex is hk. You think opposite on h. H is always inside the absolute values being subtracted from x. So if I asked you what number is being subtracted from x, it'd be 0. There's no number in there. Okay, so h is 0, and k is -4. Okay, so that's your coordinate, 0, -4. So let's plot that point. 0 on the x, 0 on the x, -4 on the y, that's a dot right there. And then from that dot, you are going to rise and run according to your a value. And the a value is the fraction in front of the absolute value, and there is no number, which means there's a fraction 1/1. So you are going to go up 1/1 and put a dot there. But you're also going to go up 1/1 in the other direction and put a dot there. And you could continue to go up 1/1, up 1/1, and continue to extend this graph as far as you want to, and same in the other direction, up 1/1. And that's what we end up with, the absolute value function, the graph, which forms a V. It's a V, right? It's like you have your vertex, and then you have 2 rays shooting out from that vertex, okay? And all absolute value functions, anything that has the absolute value with x inside, like those little sticks, they end up being like two little sticks coming out of the vertex, okay? Bam, like so. So absolute value, whenever you see these 2 little sticks, remember, you're going to end up with a graph that looks like a V. Maybe it's a really wide V, maybe a really narrow V. That all depends on your a value. Maybe it opens up or down. That all depends on your a value. Let's jump to number 3. Number 3, the vertex is, you think opposite on h, and you take k for what it is. So the vertex is -2, -3. So if you do go to -2, -3 and put a dot right there, that's your first point. And then after that, you look at your a value, which happens to be up 1/1. So from that point, you go up 1/1, up 1/1, and you keep going as far as you'd like, up 1/1, okay? And you could do that same up 1/1, but in the other direction as well. I'm not talking about using the pattern backwards, up 1/1, and then going backwards and doing it this way. That's when we graph lines, but this is not a line. This is technically a piecewise function. It's an absolute value function as 2 little sticks, so you're going to end up with a V. So it goes up in this direction. Okay. Put arrows on it because it does continue forever. I forgot to mention domain and range. What is the domain of this absolute value function? Domain are your x values, and it's all real numbers. Thank you so much. So you're going to put x equals all real numbers. And what's the range? The range are your y values. So what's the range here? Y is greater than or equal to that y value of -3. It's above the -3. So you have y is greater than or equal to -3. Hint, any absolute value function is going to have the domain x equals all real numbers. Okay. Now this range is at -4 and above. And we're talking about y values here. Y is greater than or equal to -4. Jump into number 5. This is what we call a parent graph. What's a vertex? Anybody? 0, 0, right? H, K. There is no H, there is no K, so the vertex is 0, 0. Put a dot there. What's the A value? The A value is 1, so you're going to be going up 1 over 1, up 1 over 1. Same thing in the other direction. You can go as far as you'd like in both directions. And there's your parent graph. That's your perfect V graph for the absolute value function. It's called the parent graph because all other graphs that have absolute values, absolute value of x, end up looking like this, but they just are transformed slightly differently. Maybe they're wider, maybe they're narrower, maybe they have a different vertex. If we look at 5, 6, 7, and 8, all of those have the vertex 0, 0. The only difference between 5, 6, 7, and 8 is that the A value changes. Okay, the A value, it technically gets, they're all less than 1, right? This one has the A value of 1. This one's 1/2. This one's 1/3. This one's 1/4. And I've explained this before. Technically, the closer you get to 0, the closer you get to a flat line. Okay, so we'll see right here on 7. It has the same vertex 0, 0, but instead of going up 1 over 1, you're going to go up 1 over 3. So up 1 over 1, 2, 3, and put a dot right there. And same in the other direction, up 1 over 1, 2, 3, put a dot right there. As you can see, this is definitely wider. Oh, that's ugly. Sorry about that. But this is definitely a wider V. The closer the A value gets to 0, the closer to a flat line it'll become. Let's look at number 9. Now this A value is 2. So the further away the A value is from 0, the narrower it'll become. Bless you. The further away from a flat line it'll become. So this one also has the vertex at 0, 0 because it doesn't have an H, it doesn't have an K. There it is. So we are going to rise 2, run 1. There it is, rise 2, run 1. And you're going to do the same in the other direction. And whenever I do in the other direction, I don't even go back to the vertex. I mean, you could go back to the vertex and say rise 2, run 1. But if I already know I'm at that Y level, you might as well just think of the axis of symmetry, which is a vocab word we need to learn, I think, tomorrow or next week. Axis of symmetry provides a reflection. So you could imagine that there's like this reflection line going right through the vertex. And if this dot is 1 unit away, then you could go 1 unit away to plot that point, the reflected point, onto the other side. Same here. This is 2 units away. Go 2 units this way, plot that point. That's just a slightly easier, quicker way to graph or to get the coordinates. There's our graph. So if we compare that to the original parent graph, it's definitely narrower, okay? The A value, if it gets further away from 0, the narrower it gets. If the A value gets closer to 0, the wider it gets, the closer to a flat line it gets. Let's look at number 11. That A value is 4. So is it going to be wider or narrower? Narrower, right? The further away from 0, the narrower it gets. The further away from a flat line it gets. If it were actually 0, it'd be a totally flat line. Y equals 0 is a flat line, which is technically the x-axis. But the further away from 0, the narrower it gets. The further away from a flat line it gets. So this one, again, has a vertex 0, 0. And from that point, I go up 4 over 1. And I go to the other direction as well, or reflect it over to the other side. And there's my V. And yeah, for sure, this is way narrower than the parent graph. The bigger the A value is, the more narrow it gets. In the future, we're going to call that a vertical stretch. It's a vocab word, vertical stretch. But right now we just conclude the bigger the number it is, the bigger the A value, the narrower it gets. The closer to zero the A value is, the closer to zero the A value is, the closer to a flat line it'll get. Because if you had y equals 0, that would be a flat line. So the closer to 0, the closer to a flat line. The further away from 0, the more narrow it gets, further away from a flat line. 13. Finally get to some fun stuff here. We all should know that the vertexes think opposite on H. Take K for what it is. So the vertex is HK, which is what? Negative 1, 2. Let's go to negative 1, 2, put a dot right there. And then from that point, I'm going to rise and run according to my A value. So I am going to go down 2 over 3. Down 2 over 1, 2, 3, and put a dot right there. And I want to do that into the other direction as well. 1, 2, 1, 2, 3. Put a dot right here. And there's my graph. Whoops. Come on. There it is. With the arrow right there. Arrow right there. Oh yeah, I haven't been stating domain and range. I'm sorry. Domain, super easy. X equals all real numbers because it does go to the left and to the right forever. The range, or your y values, up and down, and obviously it doesn't go up and it only goes down forever because it has arrows going down. So it doesn't go up forever. So it's just at that y value of 2 and below. So you say y is less than or equal to 2. 15. The vertex is, what is a vertex? Anybody? 1, 4. Thank you. Go to 1 on the x, 4 on the y, put a dot there. What do I do from that point? Down 7 over 2. So down 1, 2, 3, 4, 5, 6, 7 over 2. I'll end up right there. And I'm going to utilize my axis of symmetry. That way it'll be easier. It's only 2 units away. So go 1, 2 units away and put a dot right here. It's a lot faster to reflect it than to go back to the original vertex and go down 2 in the other direction. I mean, down 7 and over 2 in the other direction. But you could do that if you want. Anyways, there's our graph. It's opening down. The domain, x equals all real numbers. The range, y is less than or equal to that y value of 4. What do you guys think? Okay, so we just did all the odd ones on this side. You guys could work on the even ones. Let's flip the paper over. On this side, they're not asking us to graph. They are giving us the graph, and they want us to write the absolute value function, of course, in vertex form, y equals a, absolute value x minus h plus k. So the reality is, if you look at the graph and you're able to identify the a value, which is technically your slope, right? Rise over run. And then you're able to identify the hk, and where are you going to get hk from? From the most important point of the graph, the highest or lowest point, the maximum or minimum point, which is called the vertex. So once you identify a, h, and k, you'll be able to simply plug in your a right here in front, the h right there, and the k right there. But I highly recommend that when you do this, you write it with blank spots. So when you know a, h, and k, you plug it in safely. So we have y equals a, I'm going to leave a blank spot. Absolute value x minus h, I'm going to leave a blank spot, plus k, I'm going to leave a blank spot. Okay. So the question is, what is my a value on number 1? Well, you got to pick 2 points. And a lot of times when I draw this by hand, I actually show points here, but you got to be able to find these points on your own, right? From here to here, you're going down 1 over 1, down 1 over 1, down 1 over 1, okay? So that would be a negative 1 over 1, negative 1 over 1. That's our a value. And then we need a h value and a k value, okay? Now, obviously, that comes from the vertex. And right here, the vertex is a location 0, 0. So that means that your h is 0 and your k is 0. So you're going to plug in a 0 there and a 0 there. Now, that is the correct function. However, we could make it look nicer. You don't need a negative 1 over 1. You could just say y equals negative. Absolute value. And you don't need a x minus 0 in there. You could just put x because x minus 0 is x. And you don't need to put a plus 0 at the end. you could just leave it blank. So this is the nicest, simplest way of writing the function of this graph. So once again, it's as simple as this. Memorize vertex form absolute value functions. Identify the a value, which is technically your slope from 2 points. And then identify your vertex. It's either your highest point or lowest point, depending on if it opens up or down, which technically depends on if the a value is positive or negative. And then you could plug in your h right there and k right there. Let's take a look at number 3 here. So once again, you want the a, the h, and the k. And once you identify that, you're going to be able to plug it in with blank spots. Y equals blank spot, absolute value, x minus blank spot, plus blank spot, right? So the a value is the rise over run. So I'm going to put a is rise over run. So if we look at any 2 points from the vertex, up 1, over 2, so the slope is what? 1/2, okay? Now, if for some reason you make the mistake of looking at it from this point to that point and you're thinking, oh, it's going down 1 over 2, that's going to be wrong, and you should recognize that it's wrong, because if you put negative 1/2, that means that it's opening down, and we know it's opening up. So up 1 over 2 is the correct slope. So the a value is 1/2. And the vertex is this point right here, the lowest point, the minimum value, the most important coordinate, the most important location. And that location is 1, 2, 3 on the x, 1, 2, 3. So 3, -3 is the vertex hk, 3, -3. So knowing that vertex, you know your h value is 3 and your k value is -3. Now, some of us might be thinking, wait a minute, don't we think opposite on h? No, that's only true when you're looking at the graph and you're trying to get the h from that. When you're looking at the function and you're trying to get that h from that function. But when you have blank spots here, what belongs in here? The h belongs right here. And what is h? H is 3. So you're going to plug in that 3 right there. And what is k? K belongs out here. What is k? K is -3. You're just going to put a -3 right there. So I always say write blank spots. And then simplify it if you can. What do I mean by simplify? Sometimes you're going to end up with a negative in here, and a minus negative changes to plus plus, but that doesn't happen here. You just plugged in the 3. It says x minus 3. That's good. Over here, plus minus 3, you don't really need a plus minus. You could just change that to a minus. So your final simplified one would be y equals 1/2, absolute value x minus 3, close absolute value minus 3. Number 5. All right, so this is what we want. Y equals a, absolute value x minus h plus k. Again, I recommend rewriting it with blank spots. So you have y equals blank spot. We're going to put an a there later. Absolute value x minus blank spot. We're going to put our h there later. And then plus k, we're going to leave it blank. We're going to put a k there later. So if we can identify the a, which is from here to here, it's going down 1, 2, and over 1, 2, 3, 4, 5. So the a value is -2 over 5. So you put that in right there in the a spot. And then you look at your vertex, which is the location -1, +1. So if you know your vertex is -1, +1, then you technically know your h value and your k value. Your h is -1. So you're actually going to plug in that -1 value. Don't think opposite. You just put it in there. Because if you wrote it out with blank spots, you're going to soon see that the minus is going to change to plus. And that's how it kind of becomes opposite once you have your final function. And the k value is a +1. So we're just going to put a 1 out there. And like I said, simplify whatever you can. That would be changing the minus to plus. Final equation should be y equals -2/5 absolute value x plus 1, close absolute value plus 1. Number 7, y equals blank spot, absolute value x minus blank spot, close absolute value plus blank spot. What is the a value, ladies and gentlemen? From here to here, what's the a value? Is it -1? -2 over 1. Okay, negative 2 over 1. So we're going to put negative 2 over 1. And then what is our vertex? That's the location, 1 on the x, 4 on the y. So the vertex is 1 comma 4, which means our h is 1, our k is 4. So we put a 1 right here, a 4 right there, and technically we're done. The only thing you could do to make this look nicer is write this as a regular negative 2. Number 9. Okay, number 9. So again, y equals blank spot, absolute value x minus blank spot, close absolute value plus blank spot. Our a value from one point to another, you rise 1, you run 3. So the slope is 1/3. And the hk, the vertex, this most important point, that is the location negative 2, negative 3. So if you know that this is negative 2, negative 3, then technically you know your h is negative 2 and your k is negative 3. So once again, the a value was 1/3. That's why we put that right here. The h value is negative 2. That's why we're going to put a negative 2 right in there. And the k value is negative 3. That's why we're going to put a negative 3 over here. Now, the easiest way, or the nicest function you could actually produce would be to simplify by changing the minus minus to a plus plus to a regular plus, and to change this plus negative to a regular minus. So here's the nicest looking function here for this graph. 1/3, y equals 1/3 absolute value of x plus 2, close absolute value, minus 3. Moving on to number 11. Once again, y equals a, absolute value x minus h, close absolute value plus k. Let's rewrite that with blank spots. Y equals blank spot, absolute value x minus blank spot plus blank spot. When we look at 2 points to find the a value, which is like the slope, it's from here to here. So that would be going down 1 over 1. So the a value is technically down 1 over 1, which we could just say is minus 1, or just a minus sign. Ultimately, it's just going to be a minus sign in front of that absolute value. And then the vertex itself, that location, is 1, 2, 3, 1, 2, 3. So negative 3 is the vertex. Negative 3, which means that our h is negative 3 and our k is also negative 3. So you're going to plug in the negative 3 right in there and the negative 3 right there. Simplifying it, it would be y equals negative absolute value x plus 3 minus 3. So it really does work out where when on the other side of this worksheet, when I said graph this, you would have to think opposite on h. I mean, yeah, the opposite value of h, or of this, h is the opposite of what you see here, which is negative 3, not positive 3. Moving on to number 13. We have y equals blank spot x minus blank spot plus blank spot. The a value, looking at the slope, it's going down 1 over 1 from that one blue dot to the other. So that means that the a value is down 1 over 1. And then we have our vertex right here. That's the location 1, 2, 3, 1, 2, 3, 4. So 3, comma 4 is the vertex, which is the h and the k. Put in a 3 right there, put in the 4 right there, and there's your function. The only thing you could do to make it look nicer is just change that negative 1 over 1 just to a regular negative sign. And we are done. Moving on to 15, last one on this video. We need to find our slope, pick 2 points. That means that it's going down 1 over 1. Let me rewrite my function. Y equals a, absolute value, x minus blank spot plus blank spot. So we did say that it went down 1 over 1. So that is our slope, down 1 over 1. Our vertex, the most important point, is at the location negative 2 comma 0, which means our h value is negative 2. So you plug in negative 2 right in there. And the k value is 0. You have a 0 out there for k. So that is your function. However, you can make it look nicer by rewriting it as y equals, you don't need a negative 1 over 1. You just put a negative absolute value. Instead of a minus minus, you could put plus plus, which you just need 1 plus value. So x plus 2, close absolute value. And obviously adding 0 doesn't change anything, so you don't even have to write that. There's your final function of this absolute value graph.